All right, so how many sets of parentheses do I need? Two. Okay, Whitley, help me out here. 4 times something equals 28. 7. And whatever I do to the bottom, I have to do to the top. Aiden, help me out. 7 times something equals 28. 4. So 3 times 7 will be the numerator for the first fraction. So that means 3/4 is equivalent to 21/28. If I simplify this, what will I probably get? 3/4, okay? And 1/7 is equivalent to 4/28. So 21 plus 4 is 25. Do 25 and 28 share a factor?
No, other than 1.
So it's simplified, right? Okay, let's look at the next one, 4 and 8. So we're going to do least common multiple with 4 and 8. And this won't take you very long. Stop, skip counting when you get to the answer. I'm done. I have a match. So sometimes one of your fractions, the denominator will not change. So the new denominator is what, boys and girls? 8. That's a lot smaller than 32 if I would have multiplied those. Okay, so make sure you do it in your head. 4 times something equals 8. 2. And 8 times something equals 8. 1. So that one doesn't change at all, does it? And eventually you'll get so good at this, you'll just write down 9/8 right away. You won't even do anything else with it because you'll know. And there are lots of tricks for figuring this out, and you'll get better and better at it. So 2 plus 9? 11? So I've got 8/8 plus 3/8 equals 1 and 3/8. Okay. Let's keep going. It'll work. We'll find out. When we push play, we'll find out, won't we?
Yep.
So take a look at 8 times 7. Now remember I said you're going to get some of these memorized and you're going to know. But let's count by 8s to start with. Just count by 8s. You say it, I'll write it. 8,
16, 24, 32, 40, 48, 56.
Okay, stop. Now count by 7s, I'll write it.
14, 21, 28,
Oops.
35,
35, 42, 49.
56.
So pretty much, what's the best strategy for
56.
Right. So like I said, once we try a few and we get them memorized, you won't have to go through this in your mind or even on paper. You'll just know that 8 and 7 do not have anything smaller than 56. Okay, JC, 8 times something equals 56.
7.
So 3 times 7 is 21. Sorry, 7 times something equals 56. So 3 times 8 is what? Now 21 plus 24 45. And what we have to figure out, does this need to be simplified?
Yes.
Do they share any factors? Some of you are saying yes, some of you are saying no. Technically, we could put them on a T-chart and do it that way. But here's what I'm going to do. I'm going to talk you through it a different way. So I know 9 times 5 is 45. Okay? Does 9 or 5 divide into 56? 3 times 15 is 45. Do 3 or 15 divide into 56? No. So it's simplified. You'll get better at that as you go along too. All right. Take a look at D. 9 times 7. Think about that.
I have fun.
What do you think?
Oh, I didn't find out the answer.
Oh, you didn't find out the answer? You just thought about it? Okay, what if I were to count by nines for you, and you tell me when I get to a multiple of 7? So you're thinking about the 7, and I'm going to say the 9s, okay? Ready? 9. No, you think about the 7. I'm going to say the 9s. 9, 18, 27, 36, 45, 54, 63. Right, that's the smallest one. So 63 is the common denominator.
You could have just gone 9 times 7.
I could. And you know, you'll, like I said, you'll get better at this. Worst thing that can happen if you do 9 times 7 and you shouldn't have, you'll just have to simplify it.
Oh no.
And that's not a big deal, really. We're getting better and better at that. So 9 times what equals 63?
9 times 7.
So 4 times 7 is
28.
28. And 7 times what equals 63?
9.
So 4 times 9.
36.
Now, if you don't feel confident adding these two numbers in your head, just write down the standard algorithm and add them that way.
We were one over.
Right. So the answer to this problem, 63 63rds plus 1 63rd.
Equals 1 and 1 63rd.
Good. 1 and 1 63rd. Okay, let's keep going. What do you think here? Multiply the denominators or skip count to find?
Multiply
Multiply the denominators. You're right.
15.
15. That's your first step. Come up with a common denominator. Write it down. So 5 times something equals 15.
3.
Good. And 3 times something equals 15.
5.
My answer?
13 15.
How do I know that's simplified?
Because 13 is a prime number.
Very good. So smart, Block 4. Take a look at F. Multiply the denominators or least common multiple. You think it's 12? Let's see. Because if I multiply them, it's going to be what?
24.
24. So let's see if we can find one smaller than 24. 4, 8, 12, 16, 6, 12. Think I found it.
Would you look at that?
Would you look at that? Zane was right. So what's my common denominator?
12.
12. Okay, I want you to do the rest of this. I'm not gonna say anything, and then I want you to look up, check yours with mine.
Okay.
When Mrs. Hager's done with Saturn, she said she will dismiss class. Mm-hmm.
Carol, wait, let me get that.
Okay, I want to skip over to H because it looks a little different. Now, what are some ideas for what I could do with that one? Because it's definitely there. And I can't just ignore it. So first of all, let's talk about what I could do with the 1. Give me some ideas.
You could just make it to 10 cents.
Okay, so I could change the 1 to 10 cents.
That's what
I could. And add 3 things. Okay? Any other ideas? Jules?
You could make
I could put 10 cents in parentheses, right? Emma, what do you think?
you could take off the 1 and add it at the end.
I could move the 1 around. I think I'd rather do that. Someone in another block said, well, why couldn't I just make this 11 tenths? Yes, you could. But to me, it seems easier. Commutative property of addition. Can't we just move numbers around? We can. We just can't forget about it over there. So take a look at 4 and 10. Multiply the denominators or find the least common multiple. Don't tell me what it is. You're right, Justin. Tell me when you give me a thumbs up when you figure it out. Okay, what'd you get?
Look at that. 20.
20. So my common denominator, and what would it have been if I would have multiplied the denominators? 40. It would have been 40. So we would have had to simplify. Oh, by the way, put your 1 on there. Maybe you won't forget it if you keep moving it down. Okay, so 3/4, 1/10. 4 times something equals 20. 10 times something equals, that's okay. So 15 plus 2
17. Plus 1.
plus 1. 1 and, gosh, 1 and 17 20ths. Remember, this 1 is like 20 20ths.
You could have gotten the same answer.
I could have. If I would have done 10 11ths, I would have got the same answer. If I would have done 10 tenths, I would have got the same answer. Okay? But 1 and 17 20ths is my answer. All right, let's go down and I want to read this problem to you. Whitney says that to add fractions with different denominators, you always have to multiply the denominators to find the common unit.
No.
For example, 1/4 plus 1/6 equals 6/24 plus 4/24. Show Whitney how she could have chosen a denominator smaller than 24 to solve the problem. Should we just show her our least common multiple strategy?
Yeah, let's just put that.
Okay, because it says show, and you already know it's 12. Did we just do this?
Yes.
So 4, 8, 12, 6, 12, circle it. I just showed Whitney what to do. Go ahead and write the same thing. Could you explain this if you had to?
Yes, but we don't have
But we don't have to because it says show. Then it says solve the problem.
Of course. There was a catch. I knew it.
So let's solve the problem, but we've already done the hard part. And it really wasn't very hard. So was it 1/6 plus 1/4?
1/4 plus 1.
Really? Oh well. Four times something equals 12. What is it?
3.
6 times something equals 12. 3 plus 2 equals
5. And 5 is a prime number.
5 is a prime number, so it's already